Hello, hello, hello. Am I live? Let me check it once. Yeah, okay. So we are live. So hi all. Today as well, the agenda is Leetcode DSA questions. I have a list of questions which I'm solving. So I'll continue on this list. Yesterday, I think we left at this first positive, missing positive. So today I solved this one, string compression, 0, 1 matrix and its longest valid parenthesis. I've solved it before the stream. So now I'll continue on this list. Let me search swapping using a linked list. I'll also share the problem in chat. Grinding questions, solving 171, swapping nodes in a linked list. Okay. So uh, this is the first time I'm solving any linked list question in Java. So previously I used to code in C++, but now I have changed my language to Java. So yeah, I am coding. I uh, write the code in Java. Let me check. Yeah, okay. Stream is all good, I think. Okay, sure. So let's continue. What is the question? Starting moves in a linked list. You are giving the head of a linked list and an integer k. Okay, okay. Return the head of the linked list after swapping the values of the kth node from the beginning and the kth node from the end. Okay, so two basically means the second node from the start and the second last node from the end. I just have to swap them. Okay. Okay. So so uh, we have list node. We have a value and yeah, obviously pointer to the next node. They have been given. Okay. So yeah, obviously we'll have to calculate the length of the list. Okay. And we'll have to find the nodes basically which nodes do I have to swap, and then we can just swap the values and return the node, the head node, right? I have to return the head node, right? Yeah, okay. So it looks simple. Let's just try solving it. So list node current. Okay, yeah. So in Java we don't have pointers, so simply I can start list node current is equal to head while current not equal to null, uh, n plus equal to 1, current equal to current dot next. Okay, current dot next. So we start from n equal to 0, current is at 1, so we increment 0 to 1, we move next, 1 to 2, move next, 2 to 3, 3 to 4, 3 to 5, then current dot next equal to null, so we stop. So we get the length of the linked list. Okay, now we have to figure out the two nodes which we have to swap. Okay, so I can call them node 1 and node 2. List node, yeah, okay. So for the first node, what I have to do is, now it is given the list is one index. Basically, when this is second node, then in the one two, okay, second node. So I can start and I can move till k, and I can say node 1 is equal to node 1 arrow, sorry, node 1 dot next. And for k, basically like here is 2, so so from second last basically means in this uh, question fourth node, right? So how do we figure that out? 5 is the length of the n will be 5, and yeah, we can do n minus k plus 1, n minus k, so 5 minus 2, 3 plus 1, 4. Yeah. So n minus k plus 1. I plus plus node 2 0 2, node 2 dot next. So we have found the, yeah, sorry, node 2. So we have found the two nodes. Now we just need to swap. Now basically swapping two nodes would mean swap them by values. So we just have to get the node value, node 1 dot value. So node 1 dot val will be equal to node 2 dot val, and node 2 dot val should be equal to 10. Yeah, so we have swapped, and now we can just open the head. Okay, this is an easy problem. I don't know. Do we? I think I can just submit it. Hmm. Okay, okay, yeah, pass. Because it is an easy problem. There is not much to do. Linked list questions are generally easy. Like generally, it's just handling the next previous pointers and you can get the stuff done. Show the elements in an array, and conversion, sharp the required, rebuild. I don't know why it is telling so much stuff. Why do I have to rebuild? I don't have to rebuild. I don't know. Yeah, we just need to swap the values. Swapping the rows could be a tougher variation. But anyways, we are done with it. So let's just mark it as done and move ahead. Maximum profit in job scheduling. Mm, no, sorry. Maximum profit in job scheduling. Oh my god. We have n jobs. Okay, it is a hard problem. Tagged as hard at least. We have n jobs where every job is scheduled to be done from start time to end time. This is start time, this is the end time. We have any jobs. Every job is scheduled to be done from start time to end time. Obtaining a profit of I. Okay. You have given the start time, end time, and profit arrays. Okay. Maximum profit you can take such that there are no two jobs in the subset with overlapping timings. Maximum profit you can take. Okay. So you're not you will be able to start another job that starts at X. Okay. So start time is this and end time is this. So basically job will starts at 1 to 3 and profit is 50 from that. So we have this. So it is saying that to maximize the profit, let's just do the first and the fourth job. So 1 to 3 and then 3 to 6. Okay. Okay, 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 okay. Okay. So, uh, so start time, end time again. Mm-hmm. Let me check the topics. Array binary search again. So yesterday few questions came like few questions which we were doing were of binary search and I was not able to do that today as well. We have received a binary search question. Let's see if we are able to do it or not. Let's see. I don't know. I mean, I may not be able to solve it with binary search, but let's say if we can figure out the brute force to it. Mm, so we have this. So what if we try all combinations? Basically, trying all combinations of whatever the jobs which we can do. Yeah, because I have a list of jobs. So if I do the, I mean, I can check. Suppose if I say let's say I'm doing job one, and then I can uh, try to check if I can do the second job as well. But since it is ending at three, I'll not do the second job. But then another variation would be we will not do the first job and then we'll immediately move to the second job. So in this like this, we will try to simulate all the possible chances, all the possible situations, and yeah, then we can figure out the max profit. So somewhere like DP, not exactly DP, but somewhere like DP. So let's see. Basically, um, uh, uh, so I want start time and end time. Basically, I want to sort start time and end time, but yeah, I want to sort by start time, right? So like since they are two separate arrays, I need to maintain one common array for both of them. So I can have a common array and I'll have the start time and the end time and the profit from that task. So yeah, uh, we can iterate through the given arrays, and in zero I'm adding start time. Uh, one I'll add wait one I will add end time, and here we'll add the profit from that task. So and now I have to sort it. So I can just sort it. Arrays of sort. First provide the array name and then the condition. So basically we're putting into the right. So p of zero minus p of zero. Yeah. Okay. And now I have to simulate all the scenarios. Okay. So what we can do is Um, so basically, we will be simulating a scenario. So there we will have a recursive function. Okay, let's just call it f for now. It is a recursive function, and we'll have an index. Now, obviously, if our index which is n, so let's just give it n also, and I think I'll also need the jobs thing here. So jobs. So if index is equal to n, basically it will return the profit. Yeah, it will return the max profit. So we have missed the last, basically it is an invalid index, so we have returned 0. Now, we have two choices. First choice is uh, take up this task, take up the current task. So basically, we are at index, whatever index we are at, and we are saying I'll do this task. Okay. Now, if I'll do this task, okay. So there is one more scenario that I can only do this task. Suppose for one I can always do the first task. For second task, I have to ensure that its starting point is less than the end time of before. So I need to also have the last ending time, last end time. I need to have that with me. Okay. So yeah, take up current task is 0. Now I can only take up the current task if uh, basically if for the current index the start time is greater than or equal to the last end time. Correct? Only then. So only then I will take up the current task. Sorry, I'll take up the current task and I'll say, so now if I take up this current task, I'll get its profit, correct? I'll get the profit from the task. And now we can continue our calculation on the next index and last end time. Okay, now end time would be the end time of this particular task. Okay, and end jobs. Yeah. Another option I have is to skip the task, skip task. Okay, I may choose not to do this task. Okay, if I skip this task, it means I won't have any profit from this task, but I can move on to the next index, and the last in time will stay as it is, and in jobs. And this I should return the maximum value of take up current task, comma skip task, and we can start the iteration from 0 comma minus 1, f of 0 comma minus 1. Like we are initializing last and time as minus 1 and passing this and passing this. Wait, I think I'll have to handle this here. So if last and time is equal to minus 1 or of this. Yeah. So this is a DT brute force DT approach. 5 into 10 to the 10 raised to the power 4. Okay. So we can optimize it definitely by memoizing the memoizing our this our code. So now we have two variables. Okay, we have two variables. So memoization should handle the two variables. So we need a DT vector. Let me just create a DT vector. We have index and last and time. Okay, so here we are only storing the basically whatever maximum value I'm getting from this index, from the current index. Okay, okay. Let me check. I'm now solving. Let me just add the question number in chat. Maximum profit in job scheduling. Yeah. So this is the basic uh, recursion. Yeah. Where we are just thinking of all the use cases, all the scenarios we can create. Okay. So, 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 so. Actually, if we memorize it based on last and time, the last and time can be anything, or the last and time will be capped at this last and time of our given array. Okay, basically end time constraint for end time is 10 raised to the power 9. Okay, so okay, but if we create a DT of this start time, basically the index and this end time, it would be very huge. So we cannot memorize it in the regular way. I think that is why the binary search tag is given. We need to add binary search. Let me go through few things. What does the major think on DP? Sort the elements which are defined as resistant. Use binary search to get the next index for DP transition. Okay. Use binary search to get the next index for the DP transition. Basically, if we are trying to memorize it, the bottleneck is the end time or the last end time. Okay, so we need some way to calculate that last end time. That's it. That is the only thing causing issue. The last end time. What does the discussion section say? Topic testing of DP. Okay. It is important to understand the concepts of Photoshop similar following tools to be useful and after understanding the need for optimal solutions. I'll just open these links. I'll go through them after the stream. Confirm. It is easier than coming up with a more environmental specific. Okay. Uh, Recognize the overlapping subproblems. This is correct. How should we transition from environmental to take optimal way of finding the next person? Most notable problems leverage a sorting method. Often use a kind of sorted to an advantage in searching for the next available time. Okay. We need to find the next job index which we can take. Right, next job index. So we can avoid this last in time. In the reverse management, we should remove the index of current task. When you do this current task, find the index of the first next task whose starting time greater than equal to ending time. This can be optimized using binary search. Okay. ठीक है. So we have to have a DT, but the DT will only be for the current task, which is the index. For last end time, we have to avoid it and we have to try to find the index of the first next task. Okay, okay. So, this is a good tip. So, mm, if we try to follow what this person is saying, we'll have a DT. So let me prepare a DT which will hold the index. Okay. So yeah, and I can fill the DT with -1, and I can call this. I'll also need DT in here now. Let me pass DT in here. Let me copy this and add it to the function signature. Now, basically here I can add it with DP of IDX not equal to -1. We can return DP of IDX. Now, if you take up this current task, you have to do this. Now, here we are removing the logic of last and time. So, I'll comment that out. And for now, here I can just do jobs of IDX2 plus our load on this. And we are removing last and time. So, let me remove it. And commodity jobs. This is the take up current task. So let's comment this part. And if we skip, we just skip, move to this and DP and DP. But yeah, uh, we cannot move to the direct index, next index. We will have to find the next index where we can go because we have taken up this job. Okay, if we are skipping, it is totally fine. But now, if we are taking up this job, we are taking up this current task. We need to figure out the next time index. Correct? Next time, yeah, or the next index of the job I can pick, right? So that I need to figure out. In next task index. So okay, we'll add some logic here. When you do this current task, find the index of the first next task whose starting time is greater than equal to ending time of current task. Whose starting time is whose starting time is greater than equal to the ending time of next current task. So let me try to find. Okay. So see, uh, what options do I have? Since everyone is, since the tag says binary search, see the options I have is the next index, right? This this is an option for me. And what is the max I can do? Up to n minus one. Okay, up to n minus one. I can go up to n minus one. While low is less than equal to high, and mid is equal to low plus high by 2. Now, if this is the job, yeah, and this is the starting time. So if its starting time is greater than equal to the current job's ending time, current job is IDX 1, then uh, we can take this right index of the first next. So we can take this up because its starting point, the starting time is somewhere after or is equal to the current ending time. So we can take this. So let me create that index. Next task index, initialize with n. Here I say I can take this. So next task index should be mid, and we can reduce our window. We can reduce our window. Else we can improve our window. This is it. This is it. After that, I'll have next task index, which will be used here. I sorry. Next task index. Yeah. Okay. And now here we don't have to take this. Let me check. Does it work? Okay. Let me submit it. That is a good question. Actually, this binary search is never intuitive in interviews. That is why it is tough. But question is good. And there are only 35 test cases. Okay. Anyways, so it's done, but it's hard. It's a hard question. Let's mark it as the alien dictionary. I think I've solved this question recently. Alien dictionary in Leetcode, I think it is premium. It is a premium question. Uh, uh, yeah, it is a premium question. So let it be. This is on CFG. Let me just mark house robber. House robber. House robber solving 198. House robber. Okay. So here, you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected. So we cannot break into two adjacent houses on the same night. So it's an easy problem. Okay. So I'll have a function which will return me the value. So here I will be at an index, I'll have int and I'll have nulls. Here I'll have nulls. So if we have surpassed, if index is greater than equal to n, let's just return 0. Otherwise, otherwise, I can either rob or not rob. If I rob on this particular, if I rob this particular house, I can get the amount present here. Plus, I can get this money in from this house, and then I can move to. I cannot rob the next index. I have to rob the alternative house. Right? Basically, I have to skip one house, and yeah, I skip one house. But if I do not rob, then I will not get anything from this house. But I can rob the next house. This is it, and I have to return maximum I can make via this. I maximum I can earn by this robbery. So yeah, uh, this is the two sum of b. So we can return f of 0 and nums. Let's check what happened. Do not drop. Now we need to optimize it. Optimize this means minimize it. So I just need a dp vector and it is saying sorry arrays dot fill dp with -1 passing dp in here, copy this, pass it here as well. If dp of idx not equal to -1, return dp, sorry, return dp of idx. And in here I can copy paste, basically, sorry, uh, populate dp of idx. Yeah, so we have memoized. Further, we can also tabulate the approach, but I think this is easy. I mean, we can obviously tabulate this approach. So let's just submit it and close it. Yeah, house robber is my favorite problem because it is a very easy problem. Now, rotten evidence is rotten evidence is let me now solving 994. rotten oranges. Okay, so what is the question? We have been given a grid. We have some different kind of fruits, different kind of oranges. Zero means empty cell, one means we have a fresh orange, and two means we have a rotten orange. Okay, every minute any fresh orange becomes rotten. So basically, every fresh orange will become rotten if it is coded originally adjacent to a rotten orange. Minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. Hmm. Okay. So basically, what we will do is we will. I switch to C++ sometimes. So yeah, what we have to do is uh, we will have a queue, use a queue, and we will now uh, what should I store in the queue? Basically, what all I should store in the queue. So I'll iterate. So we are only concerned about the rotten oranges because initially we have some X number of rotten oranges. Okay, so we will add them in a queue and then we'll perform DFS. So what we will do is if grade of ij is 2, if it is a rotten orange, then we will add it to our queue. So um, this is a info. So what? So I need the I need the j. I will also store a 0, which is basically the number of minutes that have elapsed for it to become rotten. So since it is rotten already, I'm saying 0. Okay. So now I can do q dot offer info. Okay. So yeah, my queue is built. Now I just have to do DFS, not q dot is empty. Also, I need the 4 directions. So x direction will be -1 0 1 0, and y direction 0 -1 0 1. Yeah. So now what will happen is, uh, let's say current x is q dot t dot q dot t 0. Current y is q dot t 1, and current time. So current t basically means current time is this, and we will remove this element. Now from this we will move to all the other cells. Okay, so k equal to 0, k less than 4, k plus plus. We are moving to all the other cells. Okay, like all the 4 directionally adjacent cells. So in k0, k4, k plus plus, what we have to do is uh, int updated x would be current x plus x of k. Int updated y would be current y plus y of k. Also updated time. Now see, okay, let me not add this here itself. First let's check if it is valid. If update x is greater than equal to 0 and it is less than 10, and update y is greater than equal to 0 and update y is less than m, less than n, so it is a valid index. Now if it is a rotten index, yeah, it has to be valid index, and if it is sorry, if it is a fresh orange, because we have already, this is a multi-source VFS, so we have already added all the rotten oranges. So now we are trying to add all the fresh oranges. So if grade of this is equal to, if it is a fresh orange. Yeah, fresh orange. Basically means if it is a 1 is equal to 1. And should I check something else? If it is equal to 1, and then I think this is fine. If it's equal to 1, then I will insert this. Uh, I am maintaining time inside the queue, right? So if it is equal to 1, we are saying, uh, wait, let me try this. Basically, uh, q dot of, wait 1 second, int temp is updated x, updated y, and time will increase with 1, q dot offer 10. Also, we'll mark this as rotten now so that we do not calculate it again. So let's just mark it as rotten. Rotten means 2. And after all of this, after our loop runs, and yeah, minimum number of minutes that must elapse until no cell has a fresh orange. And this is impossible, return -1. So at the end, every cell should have a, should be, wait, I'll have to track the time as well, right? Since it is set, we have to track the minimum time. Let's take maximum. Uh, no, minimum time initially, yeah, wait. Minimum number of minutes that must elapse until no cell has a fresh orange. No cell has a fresh orange. Uh, Here our time is currently, here I'll have to take the maximum, right? I think I'm messing something up. Let me check once. Max dot max of currently, comma, time. For now, I'm not adding the check. I just want to verify the logic. I think there is some mistake. I'll have to keep a different time grid. I can keep a different time grid. Okay, it works. Does this work? It works. Okay. Then let's handle this logic and try to submit it. Handle this -1 thing and try to submit it. So basically, uh, since we have updated the grid, we can just iterate through the grid again. And if we see any uh, fresh orange, then we then we will, return -1. So let me just iterate jls element j plus plus if grid of ij is equal to, if it is rotten, sorry, if it is still fresh, fresh means 1, then just return -1 as we are running the time. What happened? Dot class expected int I equal to 0, I less than n, I plus plus 0, I less than n, I plus plus j equal to 0. Wrong answer. 0. Oh, what is this test case? We have, we don't have any element. Basically, 0 basically means we have an empty cell, and that empty cell. Okay. See, let's try to modify the logic because this seems a bit incorrect to me. Where, so we should not have time. We should not. add time in here. Okay, we will create another time array. Okay, which would be L L, and then we will sorry we will fill it with integer dot max value. Okay, now here in grid we will only maintain the current position in our queue. Okay, but for the rotten oranges, the time should also be 0. Correct. So time is 0. This is fine. This uh, okay. Let it be. Uh, let me comment it once and time. Let me comment it once. Now here what we are doing is we are checking if grid is equal to 1. So if it is a fresh orange, also if the time required, like for this, if the initial time, if it is maximum of value, or if suppose if I reach that same orange by some other path. Okay, so what I'm trying to check is if its time is greater than the time we can get now by doing this, sorry, by doing current of t plus 1, and then this is the thing, then let's do one thing, then we will update this time of update x, update y as current of t plus 1. Then we don't need this change, we don't need this change. Okay, but now how to calculate the time? We have a grid which mentions the time required for all the oranges to become rotten. So yeah, so what we can do is we can iterate through the grid, and first what we can see is if the current grid is, if grid of ij is equal to 2, basically if it is rotten, or I can add one check, if grid of ij is equal to fresh. Basically if I have some fresh orange left, how will I understand the fresh orange is left? I'll check my time of ij. If it is equal to the digit dot max value, it means that we were not able to rot that orange, right? So here we will simply return -1. But apart from that, if we have to calculate the uh, result, obviously the output of this question, we need the maximum time, correct? So we have to see if grid of ij is equal to 2 represents a rotten orange. So we have to just check what is the time. So math dot max of uh, result comma time of ij. That's it. Hmm. Okay, this will not work. Sorry. Current t. So okay, so here also where I'm using current t, I'll have to update it to time of current x, current y. Output 0. All of these cases, what is wrong here? What is wrong? 211 110 011. So here we are writing this 2. So it will only say acha no. So if it is not equal to 0, yeah. So basically, here we are not updating the cell, right? So even after all the operations, our grid will still show 1 and 2. Okay, so we can take care of all the oranges because we have brought in them. If we have brought in them or not, that will be evident from this part. Otherwise, we can just return. So yeah, this should be accepted. Accepted solution. Yeah. So this is more intuitive and correct approach. Initially, we were adding time to this, which is a little bit incorrect. Let me check some other solutions provided by people. Let's see if we have a more elegant way of doing it. C++, VFS, let's check Java solutions. So same and they are maintaining a visited as well. You don't really need visited. Okay, they have counted the fresh oranges in the beginning, counting the fresh oranges in the beginning, and yeah, this is a cleaner approach. We should write like this: q dot offer new and updated x, updated y. Yeah. Other than that, what they are doing is they're counting the fresh oranges, counting the fresh oranges, and if it is equal to 0, if there are no fresh oranges, then they can easily return 0. Then they have taken some minutes, -1. Okay, initializing with -1. Okay, and then they're checking while size. Basically, okay, with every BFS, 1 minute is passing. That is why they're simply adding, doing this. With every BFS, 1 minute is passing, right? We are checking all the levels, right? That is why this is working. So they have taken the directions, and then uh, if it is visited is equal to 1, visited is equal to correct. Okay, they are copying it and making it rotten, and then decreasing count of fresh oranges and this. Yeah, okay. This is also a good approach. Basically, they are the second iteration which they are doing is avoidable. Which we are doing is avoidable. We can calculate the number of rotten oranges initially. Let me try this approach as well. We can count the fresh oranges. Okay. So here I'll add. Sorry, if grid of ij is equal to 1, count plus equal to 1. So we are counting the fresh oranges. And then here uh, I can decrement the fresh orange, and we can simply check if count is equal to 0, then return, otherwise less than -1. Another thing is that maintaining a minutes, so that's simply maintaining one variable. We can also just maintain the variable, and they are then doing DFS on it throughout, and then just time plus plus, and we can return time. So let me remove this part entirely. This shortens our code. We can remove this thing, and we can remove this thing. Sorry, we can remove this thing, And in here we can check that if it is equal to 1. Okay, then and here I can update. So basically we come back to our original stuff which we did, but this looks cleaner actually. Okay, this is handling that zero condition. So we are updating it. Yeah, you got offer. Okay, my bad. Not a statement. Where have I written time? Return time. I don't know. Press. Hmm. What is the issue? What is the issue? They are maintaining minutes. We are maintaining. We are maintaining the rotten. Sorry, count of fresh oranges. They have created a separate grid for the secret. Will that impact the secret? I say 2, and the secret 1. Average 0. They are returning 0. This we can add. Okay. Okay. See, there is one fundamental difference between what this person is implementing. For us, I am only looking at one particular element in the queue. What they are doing is they are emptying the entire queue at once. Okay, this is a interesting approach. This is like level order traversal. So you just remove all the elements at once of the queue, which will guarantee that in t equal to 1, so that actually guarantees this minutes calculation. That is why it is failing for us. Okay, okay. I remember this approach now. I've used this approach earlier, but I kind of forgot about it. So yeah, okay. This is a good approach. But anyways, we have solved the question with a different approach. That is also good enough. But we should keep this in also mind. Like, this is like river or traversal, and we can remove all the elements from the queue at once. This is a good approach. Okay. Okay. So this is the benefit of solving questions again and again. I've solved Rotten always for the fourth, fifth time today, I think. Let me see how many times I've solved it. So this is the eighth time I'm submitting this Rotten Oranges. Okay. Let me mark it as done. Here. Yeah. Try puzzles. Now let's go through this list. Rotting oranges is also done. Okay. Now let's solve questions from this list. Let's add a filter. Sorry, yeah, my laptop is freezing. Uh, yeah, status is status is 2B. Yeah, okay. Uh, let's solve questions which I have not solved already from 135. 86 are solved. Okay, which means 50 questions around are remaining, and difficulty is, let's pick up medium difficulty questions first. Also, one more thing is It should not be premium. It's non-premium content. Yeah. So I have to solve these questions. Minimum size sub array sum. Minimum size sub array sum. 09 minimum size sub array sum. Okay, what is the question? Given an array of positive integers and a positive integer target, given an array of positive integers nums and a positive integer target, return the minimal length of a subarray whose sum is greater than or equal to target. I have to return the minimal length of subarray whose sum is greater than or equal to target. If there is no such subarray, return 0 instead. Subarray. Okay. Subarray basically means it has to be contiguous. Okay, contiguous and subarray auto. Somewhere it tells me that I have to use sliding window, but let's see if we are able to use it. So obviously the brute force is to follow all the basically generate all the scenarios and check and figure out a solution. But yeah, I believe we can use the sliding window approach. Also, sliding window is applicable only when we do not have negative numbers on the array, because if we have negative numbers, the shrinking of the window size or the growing of the window size is not predictable. We cannot define a behavior by shrinking or increasing the window size. That is why. So it's good to see the constraints. So if you check the constraints, we can only have positive numbers. So yeah, we can go ahead with a sliding window approach. So yeah, let's just so for sliding window, like you can follow Scriber's playlist. That's the best solution, the best videos on sliding window. So yeah, okay. And what I have to return is the minimum length. If I have to return a minimum length, I will create this with n, because maximum maybe the entire array. Okay, that is right. So while r is less than n, and we will return result. But they're saying if there is no such subarray, return 0 instead. If there is no such subarray, no such subarray. Okay, so let's do one thing. Let's initialize it with a bigger value. If we stay at the bigger value, it means there was no such stuff. Sorry. Otherwise, we can run result. Okay. Now, what we have to do is we have to left is 0, right is 0, and since we have to take a sum, we also need to initialize the sum plus equal to nums of r. What it is saying is return the minimal length of subarray whose sum is greater than or equal to target. Sum should be greater than or equal to target. So how to increase how to sum should be greater than or equal to. So let's just add that logic here. Sum if sum is greater than or equal to target, this can this window can be a part of our result. Sum is greater than or equal to target, right? So inside our list, since we have to take the minimum, we take this and r minus l plus 1. Okay, and so we have to take the minimum window. Okay, and we have already found the window of positive integers where the sum is greater than the target. Okay, suppose suppose we start from this 2 plus 3 5, 5 plus 1 6, 6 plus 2 8. Sum is greater than equal to target. We have figured out. We have got it. What is the length of the salary? If you think it is 4. Okay. Now there is no point increasing the window size further. There is no point increasing the window size further. Why? Because what we are trying to look for is the minimal length of the salary, right? So we actually need to shrink the window size. So for shrinking the window size, what we will do is we will subtract L and will increment the L. So now window size is shrink. Window size is L to R, correct? So now we initially we were talking about this window size. Now when we shrink it, 2 is removed, so it becomes 3 1 2. Now 3 plus 2 6, 3 plus 2 5 plus 1 6. So now it is not greater than equal to target. So now we increment R. So let me increment R. Yeah. Now yeah. Now we have incremented R. So we were till here, right? So yeah. So we take this part now, and where was our L? Our L was this. Yeah. So this is the window now, and this is like you can try it on the code, but this is pretty much basic sliding window stuff. Yeah, we can submit the solution. Okay, okay. This is a good question. I I hope I've added it to this. Yeah. Okay. So let's move on to the next question. Game of life. Okay. Filtered non-criminal content, non-criminal content. This I've done now. It is not updating. Okay. Anyways, let's solve game of life now. Game of game of life. Now solving, yeah, game of life. Okay, yeah. What is the question? According to Wikipedia's article, game of life, the board is made up of n cross n grid of cells, okay, where each cell has an initial state, live or dead. So 1 is live, 0 is dead. Each cell interacts with its 8 neighbors, horizontal vertical diagonal. So all the 8 neighbors come into the picture using the following 4 rules. Any live cell with fewer than 2 live neighbors dies as if caused by underpopulation. So if it has fewer than 2, if it has less than 2 live neighbors, which means, yeah, if it has less than 2 live neighbors, if it has 0 or 1 live neighbors, then it will die. With 2 or 3 live neighbors, lives on to the next generation. With more than 3, dies as if by overpopulation. Okay, so if it has more than 3, then it will also die. Less than 2, then also it will die. So only 2 or 3 live neighbors is perfect. Any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction with exactly three live neighbors. Okay, okay. The next state, now here we have eight neighbors. This is important thing. The next state of the node is determined by applying the above rules simultaneously to every cell. In this process, words and less operate simultaneously. Current state, update the board to reflect its next state. Note that you do not need to return anything. Okay, so we just have to update the board to reflect the next state. So what is the next state? One is life. There are too many rules basically, too many rules to take care of. Hmm. Okay. So we can simply do the basic traversal techniques on the grid, and should be that should solve it. Let's see. Let's see. Let's see. We have a board. Okay, and now we have to take care of eight directions. Okay, so from this cell I can go in all these six directions. So I have to prepare. So we start from here minus j minus I. Basically, wait, what I'll do is I maintain dy also similarly. So we go there minus one. Then uh, we uh, we are here. So x, uh, this is x, this is also x, this is x plus one, this is x minus one, this is x minus one, this is x. Yeah, so this is minus one because we start from 0, 1, 2, 0, 1, 2 here. So this is minus one. So this would be x would be minus one, y would be 0. Then uh, when we move to the right, again x will be minus one and y will be plus one. And now we move to the right, so x stays the same, so x will be this, and y increases with y uh, increases with 1. So basically this is done. Then we added 0, these three are done. Then we come here, so y 0, 1, 2, y will increase, then we come to this right, so we say this, here also y is increasing, then we go to the bottom where x is increasing and y stays the same. Sorry, y stays the same. Then we go to bottom left where x is increasing and x is increasing and y is decreasing. And then we go to the left cell where x stays the same and y is decreasing. Yeah, yeah. This is totally fine. We have minus 1, we have 1, 1, 1, 1, 1, 1, minus 1, minus 1. Yeah, this is totally fine. Now we will iterate to all the cells. Yeah. Uh, so we need to count the neighbors, live neighbors, neighbors, or let me say live neighbors. Let me copy this. int k equal to 0, k less than 8, k plus plus, int updated I would be I plus bx of k, and updated k would be k plus by of k. Okay, it should be valid, these indexes should be valid, so they should be equal to greater than 0 and less than n. Updated j should be then equal to 0 and it should be less than n. And then, so okay, yeah, we're calculating this. So mode of updated I, sorry, updated I, updated j will be 1, and we can do count neighbors plus equal to 1. And now we can try to apply these rules. Okay, apply their rules. Now, how do I apply the rules? Basically, uh, if I create a new array, then it is very easy. If I create a new array, some, if I say return or result or updated, let's say updated, then I can simply update this array. Yeah. So, what are the okay? We can check the constraints here. So here I've counted the live neighbors. Now we can check if board of I is equal to 1. Equal to 1 means it is a live this. Then I have to check if a live cell with fewer than 2, but if 2 or sorry, if 2 or 3 live neighbors are there, then this will also be live. Okay. Otherwise, else basically means it is a dead cell. So for dead cell, the only thing I have to check is if there's exactly 3 live neighbors. So exactly 3 live neighbors, then it will become live. Now we are not updating dead because when we initialize, it will be initialized with 0. So yeah, and now we can, it is saying that we have to return the, okay, we don't have to return anything, we just have to update the board. So we can update the board. Sorry, board of IJ will be updated on IJ. So it's easy since we only have to look for the next state. But if it is asking us to do it in place, what happens is, okay, wow, it beats 100%. Okay, can you solve it in place? Update some cells first, and then use the updated values to update other cells. We represent the board using the array. In principle, the board is infinite with short variance, so that research accuracy of these problems. So, if we have to do it optimally, I mean, see, one way is when we are doing this, updating these things, right? Basically, in the initial board, we only have 0, 1. So when we are updating it, we can try using other stuff, which is like, 4, 5. 600, something like this, or 100, 200. We can use some values like that, so that we can keep a track that okay, we have updated these values. Okay, so that is one of those. So wait, let's do one thing. So here we are updating. Okay, as well. So what we can do is okay, one basically means that is live cell, right? So okay, so let's do one thing. When I'm updating, I'll make it 100, and this is a dead cell which we are saying will live up. So let's make it something like 200. Now here I have to check this, and I'll also have to check basically, and is fine. Sorry, it should be, or it should be equal to 100. 100 basically means that this is a cell which is generating. Okay. Okay, wait, we have not updated research. Let's just remove that. Okay, okay, we cannot return 200 and stuff. So, okay, so uh, we have to fix it again, right? So we are calculating the live numbers, and then we are calculating this. Yeah, live neighbors, for live neighbors calculation we require this, and then we are doing this stuff. So yeah, after this again I have to do uh, this nothing. Mm, basically only for the stuff which are changed. So if it is equal to 100, basically it means that we were trying to make it a live cell, and uh, yeah, even if it is 200, it is a live cell, right? Then it is live cell. Uh, what happened here? Okay, otherwise it would be a dead cell. It's not live. That is a interesting follow-up question. Hmm. Give me 1 minute. I shall be back. Give me 1 minute. Okay. Hi. Hi, Shetty. Your audio is a bit low. Yeah, I am using very cheap headphones. I think that is right. Uh, let's see. With time, I'll improve my audio. If you have any questions, you can add in chat. I'll reply on the chat. Do you have any questions? Yeah. So this is done. This is done. This is done. Game of life is done. This is an interesting question actually. Which year and college? I am not in college, bro. I am a working professional. I'm not in college. Okay, let's go through the discussion section. Let's check what others are saying. You need to traverse the goal in two passes. Add 2 to the value of all cells that will be live in the next generation. Test whether neighbors are live or dead. So star equal to 1. Adding 2 to mark the mark the mark. First pass is complete. Every neighbor will contain one of the following values. Right now, there is an information. Okay. Which company? Uh, uh, don't want to reveal my company, but it is a PVC and one of the exams. Exams. Yeah, it is a exam. Hmm. Which means that encoding inside original just utilize pairs which is not a encoded sigma. They represent the board. What if the matrix is too big that can be stored computing RAM? I subscribe for watching DSAS Java. Please continue daily questions on this one. Yeah, I mean, like right now I am doing DSA. Maybe sometime I can do stream on uh, uh, low level design or HLD. So even if I do LLD, that will be on Java only. So I think that will help you. I am an intern now. Good, good, good. And I plan to do live streams on LLD, HLD as well. So even if I do LLD, it will be using Java. This problem is a meaningless nonsense. That is also correct. Uh, Java is even readable, not turning the reference entirely. Okay, anyways, we are done with this question, so let's move on to the next question. Knight probability in chessboard. Okay, this knight probability in chessboard. 688. Now solving. Yeah. Okay. On an n cross n chessboard. On an n cross n chessboard, a knight starts at the cell row column and attempts to make exactly k moves. The rows and columns are zero indexed. A k starts at the cell. Oh, a knight starts at the cell row column. So we have been given the starting cell for the knight and attempts to make exactly k moves. It will make k moves, which is also given. So rows and columns is to top left is 0 0, so 0 1. Okay, so our basic array or matrix indexing is there. Has 8 possible moves it can make as illustrated below. Each move is 2 cells in a cardinal direction, then one cell in an octal. This is fine. It chooses one of the 8 possible moves uniformly at random, even if the piece could go off the chessboard and moves there. Full stack developer is good choice as of now for career, or else Java with PSA and SQL is good. Java with BSA and SQL is good. Yeah, I didn't understand your question actually. BSA is for problem solving. BSA is not a career option. Full stack developer is a career option. BSA is only for problem solving. Full stack development is needed in real life in offices. Okay. So yeah, what I have to do is we have a horse or a knight, and it will move at any one of the eight possible moves uniformly at random. I can use knowing until that it exactly made eight moves. K moves or has moved of the chess board. Probability that the knight remains on the board after it has probability. I have to return the probability that the knight stays on the board after K moves. I think this is uh, very. I mean, I do not expect this question in an interview. Honestly, why will someone ask this question in an interview until unless they want me to fail? Ask me walk in the park. No. But I'll skip this question. Okay, they are all only solving questions which I can expect in an interview. So let's just avoid this. I mean that BSA with Java and also SQL for good job is enough, is my question. Yeah. For interviews, BSA is a must at fresher level. At fresher level, BSA would probably be the only criteria for you. Where was we? So I'm not solving this question. Let's just pick the questions which seem or look good. Uh, add two numbers to new comments. 10, 0. Count number of teams. Okay, let's do this one. I am avoiding this night probability stuff. Okay. Count number of teams. What question is this? There are n soldiers standing in a line. One of my friends got job in Salesforce. He learned only. Yeah, Java DSA is enough for freshers, and Java I think is very vastly used in the industry. So if you have knowledge of Java, it will be beneficial at any point of your career. So that's good. If you start with Java, I mean, I started doing DSA with CPP, C++, and I think I should have used Java. I think so. But anyways, that is why I am switching to Java, and that is why I am doing DSA on Java using Java these days. So I've recently switched to using Java. Okay. What was the question? Sorry. The question is count number of teams. Let me just see the discussion section if it is a problem worth doing. Hmm. Let's see. Seems like I've done all the good questions. These are idiotic questions which are left. think I saw a question like this. Hmm. There are n flights that are labeled 1 to n. You are given an array of flight bookings, where bookings means booking for flights first to last, inclusive with seats reserved for each flight in the range. Okay, okay. Return an array answer of length n, return an array answer of length n, where answer I is the total number of seats reserved for flight I. We have n flights labeled from 1 to n. Okay, so n is equal to 5 means we have, sorry, flight 1, flight 2, flight 3, flight 4, flight 5. Okay, we have n flights and you are given an array of flight bookings. Booking is equal to booking for flights first I to last I with seats reserved for each flight in the range. Flight numbers 1, 2, 3, 4, 5. Okay, booking 1 is for, okay, for flight 1, 2, and 10 seats are booked in both of these. So 10, what happened? So, yeah, okay. So let me close few tabs. So 10 and 10. Then it says, then we have 2020. So yeah, something like this. Uh, for 2 to 3, we have 2020 seats reserved. Then for 2 to 5, we have 25, 25, 25 seats reserved. What I have to return an array of intent is the total number of seats reserved for each flight. Oh, okay. I think this is similar to range difference array technique, which we solved 2 days back. I think yesterday, or I'm not sure, day before yesterday, but we did a question with range, difference array technique, something called range array also. I'm not sure, but yeah, okay. So that's what we have to solve. Mm, so in this in difference array, we create a difference array. We create a difference array, and we will go through all the bookings. I plus plus. So start is bookings of I 0, end is bookings of I 1, and we have some seats which would be bookings of I 2. So now what I do is in the difference array we are marking the range. So for the start I will add the number of seats, and for end it is saying last is inclusive. Okay, last is inclusive. So we will update the next index. Okay, so yeah, we will just do def of n plus 1 minus equal to 6. So we did a very similar question few days yesterday or day before yesterday. Uh, Carpooling, yeah, yeah, carpooling, and then we just have to find the result. We can return the result. and we can iterate and figure out the this uh, figure out the total number of seats by the difference array. So you can read about the difference array technique. We just solved the question on this yesterday. I is already defined. Where is I defined? Oh, my bad. On which day again you are going to be live again? You can't do regular live on problem solving. I plan to be live every day. I mean, that is what I'm planning to do, but I cannot commit, obviously, okay? Because sometimes there is too much work pressure, and if I am doing office work till late, like if I'm doing office work at night, then I cannot go live, right? So I plan to do I live stream every day, but I cannot commit due to office stuff and other things. But I'll try my best. And yeah, what is the error? What is the error? Error. We are creating a difference array. Creating a difference array, right? What is the output? Output is here it will. Yeah, here we are moving from 1 to n only. Result of I is I minus 1 plus step I. Result of 0 is step of 0. Here, step of start plus equal to seeds of n plus 1 minus equal to seeds. This carrot looks correct to me. I don't know where are we going wrong. Bookings dot length. We are iterating through the bookings. Here I'm adding this up for start n plus 1. We are removing the seeds. Is equal to def of 0. Current I equal to 1. I less than n I plus plus. Result of I is equal to result of I minus 1 plus def of I. Yeah. Then what is the issue? What is the issue? What is the issue? 0, 10. Def of 0. Def of 0. Hmm. So these are labeled from 1 to n. Okay, okay. I'll have to take care of this. And yeah, because here when we are saying 1 to 2, we are actually updating 0 and 1 in the difference array, right? That is why. It's a good question, actually. Let's move on to the next question. Corporate flooding. So this was difference array technique. Okay, okay. Uh, in compression, we just did. Let me solve a question which I have not solved for long. Or let's check the hard questions. Difficulty is hard, not medium, and status is to do. And also, and of course, it should not be paid. Yes. LFQ cache. Mm, shortest sub array with sum at least k. Shortest sub array with sum at least k. Hmm. What do we have to do? Given an integer array num set an integer k, return the length of the shortest non-empty subarray of number of nums with a sum of at least k. Shortest non-empty subarray with a sum of at least k. So now it can have the negative elements, which makes it tricky because sliding window will not work here. That is why I think it is labeled hard. Okay. Okay. ठीक है. So we cannot do sliding window, but anyways, since it is asking for all the sub-arrays, we can try this approach. We can try with brute force first. Obviously, brute force will not uh, work, but let's just think of the approach and try to code it, code the brute force. So we are given an integer and an integer k. We have been given an array and an integer k. So we have to return the length of the shortest non-empty subarray with a sum of at least k. So its summation should at least be k. At least k means greater than equal to k. Okay, okay. So uh, today I think I solved the question subarray sum equals k, where we were calculating the prefix uh, array so that we can easily calculate the subarray of a middle part of the array. Yeah, so I can apply that logic here. I'll try to figure out the prefix sum. basically calculate the prefix sum. Wait, prefix sum of I, ठीक है, equal to prefix I plus nonce of I. And now I'll go through all the subarrays, sorry, and if prefix of this minus prefix of this. So if you try to visualize it, it's something uh, like so prefix sum of I is prefix sum of 0 to I, and of prefix sum of j is from 0 to j. So here we are looking at a subarray which is from I to j. Okay, I to j. If I bring it down, you will understand that j is somewhere after I. Okay, we are doing I plus 1. So this summation minus this summation is giving me this summation, this summation. Okay, so that is what we are doing, and we are checking if it is greater than or equal to a, which means it can be possible answer for us. So let's just calculate. Okay, minus I. Now here I need to maintain a result which I can maintain as integer dot max value. It should be non-empty. So there's no such scenario, then minus 1. So here I can add that logic. It is equal to this. It means we didn't find any scenario, so return minus 1. Otherwise, it return 0, return our result. And this is this is fine. Hmm. This is what an O of n square solution, even after using prefix n. And we have O of n space complexity and O of n square time complexity. Now, how do we optimize it? So it's binary search. Again, binary search came. Binary search is turning out to be a very important topic suddenly. Binary search, queue, sliding window, monotonic queue. Okay, monotonic queue. Okay. So we are, acha, if I try submitting it, it will result in TLE, right? Yeah, there is 10 raised to the power 5. So it will be TLE. Yes. So, okay, let's go through the discussion section to understand if we get some hints for the optimized approach. Sliding windows are dead and don't try to use it. Live users know. A good example of how implemented method in future location concern. You have not seen this question before. Bye bye offer. Yeah, obviously. Many questions asked in interviews are like they're they're legit unsolvable within like 30 or 45 minutes of an interview. So they can only be solved if you have done it before. Okay, so that doesn't actually test problem solving, but anyways, that is how it is. Must relearn prefix and pattern. What is okay? I got stuck infinitely. Started thinking sliding window, as in Palladian and gas station. Person understood these approaches and such as specific campaign. Recently, I can't slide before the more even if required for the best answer. Took 6 hours to solve this from scratch with DQ. After visiting and fully followed the course, I solved it in 30 minutes from scratch. New features and patterns for illustrative patterns. So I've been practicing these patterns. Okay, but after looking at this discussion, I don't think I'll be able to solve it. So I always have the passport and how I feel about it. And how to have a monotonic queue sliding with your solution. So yeah, everyone is using monotonic queue, but why and how is the question. Okay, let's move. Let's see if they have any other questions to solve. Uh, this one I'm not optimizing it. Okay, okay. There is a reason these questions are hard. Okay, it's close to 2 hours, so I am planning to close the stream. If there are any questions, please feel free to ask. The skyline problem. A city's skyline is the outer contour of the cell house formed by all the buildings in that city when viewed from a distance. Yeah, if you have a diagram like this, obviously the question is extremely tough. Anyways, so if there are any questions, let me know. Otherwise, I'm wrapping up the stream. Uh, wrapping up the stream. Wrapping up. Any questions? Do we have any questions? Too many. I don't know. When DSA preparation will be enough? We have too many questions to solve. Even after solving 500, 600 questions in an interview, you can get just any question at random. These are all Goldman Sachs questions. Questions asked in Goldman Sachs. Hmm. Okay. So seems like no questions. So okay. I am ending the stream. Thanks everyone. Thanks for watching. Thanks for watching. Let's meet tomorrow. Let's see if I can do the live stream tomorrow. Let's see. Okay. Um, and this.